Welcome again to the White Dog Garage YouTube channel. My name is Bob. In this episode I'm going to be talking about MIG welders and the things you should consider when buying one in Australia where I live. Some of the information possibly will be relevant to other countries, particularly New Zealand. My focus will be on the DIY and light industrial market. It's been quite a few years since I've used a MIG in industry. I've always regarded them as somewhat of a production machine, and my focus in this workshop is on maintenance and repair, and the welders I have generally cover that. There's been a few jobs in the last year or so where a MIG would have come in handy, and that's what made me think about getting a MIG. And I spent a bit of time looking into it, and it's that sort of information that I want to share with you in this episode. As I said before, it's the Australian situation that I'm talking about. Most of the stuff you see on YouTube is American based, and it's a different ball game. It really is. I should probably say something about terminology here. MIG is an acronym for metal inert gas, but the correct term is gas metal arc welding, GMAW. But I'll probably continue to use the term MIG throughout the video. Now, if you're going to buy a MIG, the first thing you need to do is settle the criteria of which you're going to make your selection. My needs are at the light industrial end of the market, but most of what I say will apply either to the light industrial end or to DIY. Of course, I'm talking in the Australian situation primarily. These are the criteria I think you need to consider. Electricity supply that you'll be using, the current output of the chosen welder, whether you want to run your MIG with gas or gasless, the metal you intend to weld, the duty cycle, which is another way of saying how long and how hard are you going to run the machine, your budget of course, and finally the level of support that you're going to get for the machine that you choose. Your first consideration needs to be the power supply that you have available. My electricity supply here in the garage is the standard Australian domestic one, but I do have a few dedicated power circuits with 15 amp power points. Now, if you have the standard Australian power circuits with 10 amp outlets and you can't get any changes made, then you are going to have to factor in your available power circuit to your selection of a MIG welder. Welders for sale these days should have a specification panel on them, usually at the back or underneath the machine. You'll see what the input voltage is, 240 or 230 volts usually. That'll usually be labelled as U1. The other two characteristics you need to look at are labelled usually I subscript 1 max, I subscript 1 EFF. Now you probably realise that the subscript 1 refers to the primary input circuit, the primary power supply to the welder, and you'll see other labels there that have got subscript 2, and they're talking about the output side. I max is the maximum input current that the welder will draw, typically at startup, but also when you get towards the maximum power output of the welder. EFF is the effective current draw, and this is the current that it will typically use as it is running. Now, what does that mean for your selection? The take-home message is that the maximum input current defines the circuit breaker or fuse that the circuit must have, and the effective current defines the current flow that the plug must handle. Looking at the label shown here, the maximum input current is 19.8 amps and the effective current is 12 amps. So to safely run this machine, the welder circuit will need at least a 20 amp circuit breaker or fuse, and the welder will need a 15 amp plug. There are a few high amperage welders on the market these days which come with 10 amp plugs. That sounds good, doesn't it? As an example, here is a specification label for the Unimig Viper 180 amp AC/DC TIG machine. Here the maximum input current is 23 amps and the effective current is 8.9 amps. So to safely run, the welder circuit will need a 25 amp or better circuit breaker or fuse, and the welder a 10 amp plug, which it comes with. It's one of the highlights of the advertising for it. Now, where you might run into strife is that the typical circuit breakers used in Australia for 10 amp power circuits is 20 amps. So, despite having a 10 amp plug, being able to plug it into the wall, no trouble at all, unless the circuit breaker is 25 amps or better, you're probably going to pop the circuit. And that's going to happen every time you turn the machine on and every time you're close to full capacity. Something to be aware of. So if you have an old switchboard with plug-in circuit breakers or the old ceramic fuse style thing, what you don't do is just change the circuit breaker or change the fuse wire. That's because those fuses are there to protect the wire in the circuit. And this is your most important point. The wire will be of a size to match that fuse, or the fuse is of a size to match that wire. If you increase the capacity of the fuse, that wire can overheat, it can melt, it can and it can cause the insulation to burst into flames, giving you a fire, which is something you don't need. The next requirement to be decided on is welding current. In my case, I'm looking for a maximum current of 180 amps or better. But I must say you can do quite good welds with a welder that does 130, 140 amps, typically up to about 6mm thick steel. And if you're into welding car panels, and who isn't, this welder will work all day long. Next question is, do you want your MIG welder to run gasless, or are you going to run it with gas? Gas MIG machines can always run as gasless. That's flux core in another terminology. But gasless MIG machines don't have the gas plumbing to run gas. Gasless wire, of course, is known as flux core wire. It's like a stick electrode, only instead of having the flux on the outside, it has the flux in the centre of the wire. So it's a hollow wire filled with flux. As a price difference, of course, because they don't have any gas plumbing, gasless machines are cheaper. Purely gasless machines are cheaper. You get to a certain price level and it's all gasless, and then above that price it'll always run gas. Personally, I prefer gas MIG. It's a much cleaner process, but gasless or flux core certainly has its place. The next selection criteria is what metal or metals are you going to weld with your MIG? In my case, my main focus is on welding steel. I do weld aluminium, but I typically do that either with my TIG machine or with oxyacetylene. There are subtle variations there between the two processes. Gas MIG machines can always weld aluminium, but if you want to go that way, you might also want to consider whether the machine you buy can take a spool gun. Aluminium is light, it's difficult to feed, and if you don't set it up correctly, the feed can go astray and you can end up with a bit of a wire bird's nest inside the machine or worse. With a spool gun, the wire is in a small roll more or less at the tip of the machine, and because the travel distance is much less, you don't tend to get those sort of problems, and it works quite well. I should also mention duty cycle. A rough explanation of duty cycle is it's the amount of time in a 10-minute period that the welder can run at a given amperage before it overheats. It's expressed as a percentage, and this amperage specified at 100% is the level at which the machine can run continuously. The amperage specified at, say, a 20% duty cycle is the level the machine can run for 20% of the time. Now, work on a 10-minute cycle, say you would run the machine for 2 minutes at the specified current level, and then you would let it idle for the remaining 8 minutes in that 10-minute bracket. And no, you can't run 2 minutes for that 10-minute bracket and then 2 minutes for the next 10-minute bracket in a 20-minute period. It can work like that because the duty cycle just relates to the machine overheating. And in most of the modern machines, there's a thermal cutout, which will cut out if it just gets too hot. And of course, the duty cycle will go up or down to some extent, depending on the ambient temperature. On multi-purpose welders, you'll probably see, and almost certainly will see, that the duty cycle will be different for the different functions, that is MIG, TIG or stick. Looking at the Unimig Viper TIG 180 AC/DC power spec, 100% duty cycle is 70 amps for TIG and 41 amps for stick welding. Probably digress for a minute to tell you a little story from my dark past. A long time ago, in a place far away from here, I worked at a firm that had a 600 amp welder. It's a stick welder. It was a transformer machine. You're probably thinking 600 amps could run a welding rod as thick as your arm. I don't know about that. I've never seen a welding rod that big. However, what the beauty of it was where the duty cycle lay. What it meant you could do is that you could just, with say a 4mm rod, I can't remember the sizes back then. There was something bigger than 4mm, but anyhow, let's talk about 4mm. You could run it all day long, just swapping, as the rod finished, just put another one in, just keep going, just keep going, just keep going. And that's the sort of thing you want in a business like that. So you might be, for example, hard facing a bulldozer blade, and that's just laying weld after weld, string after string of weld. And so in that situation, you want to be able to just change rods and keep going. Don't want to have to stop and start, stop and start. Now, that can do that, no problems at all. And of course, the other thing was, this thing weighed a heap. We moved it around with a crane. I guess a few people could move it. I didn't have wheels, some of them do. Anyhow, the other point being is that it had probably 30-foot, 15-metre long leads, and which means that the welder stayed in one place and you would walk off on the other side of the building just about and do your welding. And that's a good thing as well, because it means that you can get around. When you're doing a lot of welding, it means that you can just get around to do the job easily without having to go back and move the welder. These smaller machines are typically have a 3-metre lead. There's a reason for that. The current drops off with distance, but with a 600 amp machine with a good duty cycle, having a 30-foot lead, a 15-metre lead, no trouble at all, because you've still got plenty of current there to feed out to the workpiece. I've not talked about budget. Well, it's not polite to talk about money, is it? Really, it's going to be your decision. But there's a few things you need to consider. You've got the initial machine cost, of course, but with the MIG welder, you've got your consumables. There's lots of them. There's wire, there's tips, etc. There's liners sometimes, nozzles. Protecting these things goes on and on. And of course, if you go with gas, there's the cost of the gas bottle, there's the cost of having a gas regulator, gas lines, and so on, and actually the gas itself. Not to mention, of course, your welding helmet and gloves. Argon gas will work for all forms of MIG welding, but money can be saved if you're just doing steel by using a argon carbon dioxide gas mix. Finally, your choice should be guided by the level of support available for that machine. A no-no machine from a flea market or car boot sale could put you in a world of pain. Your journey into the world of MIG welding will require a host of consumables, as I said, and you'll need a reliable supplier for your chosen machine. Before I get back to what I bought, I'll give you a quick swing through some examples of what is out there in Australia. Firmly in the DIY space is the Izitu, I think I've pronounced that correctly, 100 amp gasless MIG sold by Bunnings. Bunnings is the Australian equivalent of an American big box store. Their welder is a maximum input current of 15 amps and an effective current of 6.7 amps. So it's easily able to run on your domestic power supply. It's probably only good for welding up to about 3mm or 1/8 of an inch thick steel, and 100 amps the duty cycle is 20%, so that's 2 minutes and 10. A real home machine. If you watch a lot of American YouTube videos on welding machines, you'll probably hear names like Lincoln, Miller, Hobart and Everlast repeatedly. And if we're talking about American YouTube videos, I'd just like to give a shout out to Jody Collier at Welding Tips and Tricks. Jody does some excellent videos. He does really good filtered shots of the actual welding process, close up, no smoke, just the actual arc. And he does these processes where he cuts and then etches the weld to show how much penetration you've got. Well worth a look if nothing else. Anyhow, back to the matter in question. So I'm not sure about the rest of those names, but I do know that Lincoln sells welders in Australia. Now, I've always had a soft spot for Lincoln because that was the welders, or that brand of welders was what I used when I first started out in metalworking. Anyhow, watching those American videos, I do like the look of the Lincoln MP210, but it's not a machine that Lincoln sells here. One of the machines they do have available here is the Powercraft 191C, ready to weld machine. This is one of these ones that comes with all the bits that you need, basically, minus your helmet and gloves. It's got a 3-metre Binzel MB15 style MIG torch, which is, you want a Binzel style if you can. It's got electrode lead and work return lead for stick welding, and it's got a flow meter and gas line for gas use. The input's 240 volts with a 10 amp plug, and the output current's 190 amps. It'll do gas and gasless MIG, of course, as well as stick welding. It's got the facility to take a spool gun, in case you want to use that for aluminium welding. Lincoln advertises being able to do lift arc TIG, but you'd need to buy the lead and the gas connection for that. It comes with a 0.6 and 0.8mm and 0.9 and 1.2mm rollers, which is a good set to have. And on the MIG setting at 180 amps, the duty cycle is 23%. Another one that's available on the market is one from Wire Industries Australia, typically known as WIA, the big yellow machines. Has available 180. They have available 180 amp inverter MIG. There's a maximum input current of 31 amps and an effective current of 10 amps. Comes with a 10 amp plug, but you'll need a 32 amp circuit to run it safely. At 180 amps, it's got a 10% duty cycle for MIG, and its 100% duty cycle for MIG is at 57 amps. And like the Lincoln machine, it's a multi-purpose one delivering MIG, stick and lift arc TIG capabilities. But to be honest though, most inverter DC welders can run lift arc TIG if a gas supply can be rigged. So, what was my selection criteria for buying the MIG? Well, price. I've got a budget as well. I've obviously limited with a single phase 240 volt power supply. I do want 180 amps or better welding current. I want gas, and of course with that comes gasless wire capability. I do mainly steel work, so that's something. And of course I want the support, I want the consumables readily available, I want supply backup if something goes wrong. I ended up buying the Renegade Industrial 200 amp MIG machine. Renegade Industrial is a house brand of a company called Trade Tools. It's a local company, and their nearest shop is just a short drive down the road from where I am based. So it's handy, and they carry all the consumables, etc., wire. They even carry gas, so it's really good from that point of view. It has the maximum input current of 32 amps and an effective current of 14 amps. So we're talking a 15 amp plug, and we're talking a 32 amp or better circuit breaker. For MIG at 200 amps, the duty cycle is 20%, and the 100% duty cycle is at 90 amps essentially. Price is good. I already have two other Renegade industrial machines, one of which I've had for 20 years. They've performed faultlessly during the time that I've had them, so I've got no problem with buying that brand again. And I'll make the usual proviso here: Trade Tools has not paid any contribution towards this video. They probably don't even really know I exist, other than I'm a listed trade customer on their system. This is the end of part 1. And I hope this episode has given you some good information so that you can go out and select a MIG welder for your own use. In part 2, I'll be showing you the Renegade Industrial 200 amp MIG machine going through its paces. You'll see how it runs with gas wire on both steel and aluminium, as well as flux core and stick welding. I'll show you how to set it up, what consumables I bought to support the machine, and even how to change liners for welding aluminium. So, I hope you'll join me for part 2. As always, thanks for watching, and I look forward to talking to you in the next episode on the White Dog Garage YouTube channel. Bye!